a little bit of sugar, a little bit of sulfuric acid here. I'm just going to put some sugar in this beaker for a reason. The sugar is dry sugar. There's no water here. Sulfuric acid is a strong proton donor. It wants to donate its proton to water. Sulfuric acid will actually, in some cases, try to find water where none exists. If you look at the formula, it's a little hard to read on the board. I didn't have a very good marker. But the formula for a simple sugar, take glucose, C6H12O6. The ratio of hydrogens to oxygens is 2 to 1. If you look at that formula, although there's no water here, we have the makings of 6 waters, 6 oxygens, 12 hydrogens. Sulfuric acid has the property that it will actually take molecules and find ways to rip water out of them just so it can donate its proton to that particular material. So if I just take a little bit of concentrated sulfuric acid, somewhere here I had a stir bar. I'm going to take some concentrated sulfuric acid. I'm going to dump it on this sugar here. And if I stir this up carefully, hopefully I won't make too much of a mess. If I stir this up, first thing you'll notice, things are starting to discolor here. This is turning brown. We're starting to caramelize the sugar with the sulfuric acid. It's turning dark. That dark is carbon. We've ripped out some water, and we're being left behind with carbon. So if I just beat that back down in there a little bit. So what's happening right now? The sulfuric acid wants to donate its proton to water, but there is no water, so it's going to rip the water out of the sugar. That's why we're starting to see the black of the carbon. This reaction is exothermic, generates heat. Enough heat to actually boil the water that it rips out. And so I'm going to help this guy kind of grow big and tall so he doesn't tip over on me. The sulfuric acid rips the water out of the sugar, and in doing so heats up to the point where some of that water boils. The expanding steam coupled with the carbon that is left over generates basically a carbon foam, a solid carbon foam, because we have ripped the water out of the sulfuric acid and in part boiled it. So now we've got a carbon skeleton left over. It happens to be soaked with sulfuric acid, so I don't want to handle it, but it is a solid, carbon foam. That kind of illustrates the power of a strong acid, a strong protonating agent. It will rip water out of other compounds just so it can give up its proton to that material.